Hi folks, as suggested in the last video, today we'll return to our Thomson DPL910DV VFD, but now dedicated only to the VFD since the original driver has on separate board. The goal is to create a driver with a low-cost ICs, easy to use and easy to apply to any VFD of this type. We have already used other ICs for this purpose in other videos. Today we will use the 2xSN74LES164 and 2 ULN2804. I will only use 8 grids and I will not use the 14-digit segments. If you intend to use them, you will have to add another pair of ICs, since each pair allows the control of the 8 grids or segments, or a mixed combination of course. In the example installed in the protoboard, the first pair is responsible for the 8 grids and the second for the 8 segments used. Since we are using only 8 grids and 8 multiplexed segments, we need to use a dynamic display mode. We can only activate the grid and the desired digit simultaneous with the segments of the digit we want to display. To send data, we will use a Arduino function that will send 8 bits each time, where the first byte sent will be of the segments and the last will be of the grids. We'll display the number 1 in the grids 1 and 2 on the right, since we skip the grid 0, which is the predefined symbols. Don't forget that we are using the continuous presence of the voltage in the grids and segments. This makes it is necessary to send the inverted bytes, which will result in the 3F and 9F. Note that even if I wanted to use only 6 grids with 2 dots in the separation, I had 6 grids used, leaving only 10 for the segments, which means that it is not possible to use all alphanumeric segments without adding more ICs. The 74LES164 is a shift register that allows the conversion from series to parallel. We just have to worry about keeping its MR pin with a high value. We can use, for example, one resistor of 2.2 Ks connected to the plus 5 volts. In this case, I use the pin 10 of the Arduino to control this pin. We have to provide the clock on the CP pin and the data on the AB data. It has 2 pins to data, like A and B, because it allows the input latch to control the flux of the data. Since we have 2 74LES164 in cascade, we have to provide the signal from the output of the Q7 of the first IC to the AB of the second LES164. Regarding to ULN2804, it is enough to control or to only provide the GND and the parallel connection of the whole Q's outputs from the 164 to its inputs. Note that we are using one integrated circuit that has a 10K resistor at the internal process to protect the channel. I chose this one on purpose to safeguard the Arduino, but I still apply an external 47 ohms airs in series with the 3 control pins coming from the Arduino as a precaution. As I said before, we have permanent power supply on the grids and the filaments provided by a resistor bar in parallel with the pins of the VFD itself, and of course the ULN. Since we are not using inductive loads, we must leave the pin 10 of the freewheeling diodes free. If you use this ULN2804 driver for control relay, for example, it is mandatory to connect this pin to the positive pole that will power the relay. The ULN2804 was used because it has 8 ports. However, there is the ULN2004 which only has 7 ports. There are 2 families of 8 or 7 ports and another small difference. As normal, I proceed with the change of the value present in the register to be able possible run the clock more fast and proceed with the test of the time. I don't apply special care in the value present in the matcher register. Maybe you need to adjust it a little. I know this is a lot of the wires, but it will be more easy if you think in blocks. The first block with the 2 ICs shift register the first IC receive the pin of the clock and the data coming from the Arduino. It proceeds with the move of the registers, and after the Q7 go to the input of the second IC. Each one of these ICs have 4 pins of the data in the left side and the right side. This means you have 8 bits in each IC. These 8 bits go direct to the inputs of the ULN2804 and repeat the process for the second 164. Each ULN2804 have a bar of the resistors in parallel with the output. The second IC have the same bar of the resistors also in the output. Now you have here 8 grids and here you have 8 segments, and now you can connect the way you want here. You can reverse the order, you can apply another VFD in parallel. Okay, this is 8 grids and here is 8 segments. Now you can connect where you want, okay? As you can see, I only connect the wires I need to construct the digits of 7 segments. In this case, I need connect 8 wires because the segment G, segment of the middle, have 2 parts, okay? But I only use 7 segments. The same happen with the grids. I only connect the grids I need. I connect one wire and check which is the grid, and the second, and so on, okay? About the remaining conditions to bring the panel to life, as always, I use a converter DC-DC from 5 volts to plus 24 volts DC. And take note, here we are using the plus 24 volts, okay? The 0 volts of the output of the converter go to the our GND. This means you stay with the plus 24 volts and this plus 24 volts connect to each common pin of the bar of the resistors. The filament is powered up by plus 5 volts DC through two diodes, one N4004, and you need to respect the polarity of the diode, okay? The anode go to the plus and after to the filament. Here go to the anode of the second diode and go to the GND. Here you have three resistors applied in serial to the pins of the control coming of the Arduino. Please don't forget the GND of the Arduino to GND of the panel. I use the same three buttons to adjust the clock. Clear the seconds, increase minutes, increase the hours. Okay, you can add more buttons.